Welcome to AI Frontiers. Today's episode explores the convergence of computer vision and natural language processing through 15 recent papers. We'll examine breakthroughs in multimodal understanding, from pattern recognition to true visual cognition, and discuss the foundation for next-generation intelligent systems. Today's journey maps the multimodal frontier, providing an overview of computer vision and natural language processing convergence. The discussion will cover dominant research themes, key findings, deep dives into seminal methodologies, spotlights on 3 transformative papers, and future directions with their implications. The multimodal revolution represents a fundamental shift toward bridging vision and language. This movement goes beyond isolated AI models to create integrated systems that understand context and narrative. The transition from object recognition to scene comprehension enables advanced robotics, intelligent assistants, and medical AI systems, forming the foundation for genuine artificial intelligence. Theme 1 explores integration versus isolation, focusing on building bridges between modalities. Early AI treated vision and language as separate domains, while the new paradigm develops architectures where modalities inform each other. Radford and colleagues demonstrated cross-modal learning at scale, showing how models can learn visual concepts from raw text supervision, thereby breaking down silos for richer understanding. Theme 2 emphasizes that context is king, moving beyond simple recognition to meaning extraction. This involves not just identifying objects but understanding their significance by deriving meaning from surrounding visual and textual context. Lee and colleagues showed that noise and diversity actually strengthen contextual learning, enabling models to grasp cultural concepts and fine-grained semantics, transitioning from what is there to why it matters. Theme 3 examines the shift beyond description to reasoning, marking the transition from perception to cognition. This movement goes past basic captioning to visual question answering and advanced reasoning. Cho and colleagues advanced compositional reasoning skills, creating models that infer cause, effect, and narrative while understanding relationships between objects and actions, thereby laying the groundwork for visual assistance and explainable AI. Critical insights reveal field-changing findings that multimodal pre-training serves as the new game-changer. Attention mechanisms function as universal alignment glue, while large-scale diverse data consistently outperforms narrow perfection. Evaluation methodologies must evolve to test reasoning capabilities rather than just accuracy, with internet-scale learning enabling remarkable zero-shot capabilities across various tasks. The technical deep dive into transformer architecture reveals it as the engine of multimodal understanding. Self-attention and cross-attention layers align visual and textual features, while visual encoders process images into feature vectors and language encoders process text into contextual embeddings. Cross-modality encoders fuse information dynamically, allowing the system to focus on relevant image regions for each word during processing. Methodological breakthroughs demonstrate how these systems learn, with transformer-based encoder-decoder frameworks dominating the field. Contrastive learning techniques compare correct versus incorrect pairings, while object detectors serve as feature extractors for semantic grounding. Self-supervised learning reduces labeling dependency, and multitask learning across diverse datasets enhances overall system performance. The paper of the day focuses on CLIP by Radford and colleagues, which demonstrated learning from natural language supervision. This work represented a paradigm shift by showing how visual concepts could be learned directly from text, leveraging hundreds of millions of web image text pairs. The contrastive learning objective enabled alignment, resulting in revolutionary zero-shot capabilities without fine-tuning and breaking dependency on manually labeled datasets. The seminal paper aligned by Lee and colleagues embraced scale and noise as fundamental components. The model was trained on over 1 billion noisy image text pairs, proving that noise serves as a source of strength rather than weakness. This approach achieved state-of-the-art image text retrieval results, demonstrated the scaling hypothesis in practice, and learned rich, nuanced representations from messy real-world data. The seminal paper X-LXMERT by Cho and colleagues advanced visual reasoning capabilities beyond simple association. The architecture employed separate encoders for language and visual features, with a cross-modality encoder for deep fusion. Training on an extra-large multitask dataset mixture resulted in strong compositional reasoning skills suitable for dialogue systems and explanation generation. Future frontiers indicate where the field is heading, with video and temporal understanding enabling narrative comprehension. Addressing bias and fairness in Internet-trained models remains crucial, while efficiency research focuses on distillation and sparse architectures. Embodied AI represents the next frontier for turning perception into physical action, accompanied by new evaluation benchmarks for reasoning and compositionality. This presentation was synthesized using GPT and DeepSeek chat models, with text-to-speech synthesis employing Google's TTS technology. Image generation concepts were developed via Stable Diffusion, and human experts reviewed the content for accuracy and coherence. Potential oversights may exist despite rigorous review processes ensuring quality. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archived preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the archived preprint server.